Today we're covering more properties of exponents. We're going to learn two new properties, and these ones involve quotients, which we commonly see show up as fractions. Now, when we have a quotient of two powers, with the same base, a to the m over a to the n, we simplify this by doing a to the m minus n. For instance, 4 to the fourth power over 4 squared would be 4 to the second. The reason is because 4 to the fourth is 4 times 4 times 4. And 4 squared is 4 times 4. And I know that when I have common factors in the numerator and the denominator, I can cancel them out, leaving me with just 2 4s on top. This is called the quotient of powers property. Again, the name isn't so important as much as remembering what to do when you have this setup. So if I had 8 to the 10th over 8 to the 4th, what would that become? 10 minus 4 is 6, so I'm left with 8 to the 6th. About negative 3 to the 9th over negative 3 to the 3rd. 9 minus 3 is 6, so I get negative 3 to the 6th. Let's combine it with a property we learned yesterday. 5 to the 4th times 5 to the 8th over 5 to the 7th. Well, 4 plus 8 is 12, and 12 minus 7 is 5. So I'm left with 5 to the 5th. Now we might see one that looks like this. 1 over x to the 4th times x to the 6th. Well, remember that when we're multiplying these, it's just like multiplying fractions. We get x to the 6th over x to the 4th. Then we can subtract and get x squared. The next property we want to look at is the power of a quotient property. That's where we start with a quotient, like a over b, and we raise it to a power, like m. And it's real simple. We raise the top to the power m, and we raise the bottom to the power m. The reason is, if I had something like 3 over 4 to the 3rd, I know that that would be equal to 3 fourths times 3 fourths times 3 fourths. And when I multiply fractions, I multiply across the top. So I'd have 3 times 3 times 3 over 4 times 4 times 4. And that is, by definition, equal to 3 to the 3rd over 4 to the 3rd. This is called power of a quotient property. So if I had x over y to the 3rd, what would that become? X to the 3rd over y to the 3rd. What if I had negative 7 over x squared? Well, it's helpful to put that negative with either the top or the bottom, and it honestly doesn't matter which. Just don't do both, because then they'd cancel out and become a positive. So it might be easier to look at it like this. Now when I square the top, what's negative 7 times negative 7? It's negative 7 squared, which I know is 49. Positive, because I'm squaring that negative, and a negative times a negative becomes positive. Let's combine all of the properties we've learned so far together into one problem. 4x squared over 5y to the third. Now, I can use my power of a quotient property to split this and say I've got 4x squared on top. I'm raising that to the third power. And I've got 5y on the bottom, and I'm raising that to the third power. Now I need to use my power of a product property, which we learned yesterday, to split this. 4 to the third and x squared to the third. And on the bottom, 5 to the third and y to the third. Well, what's 4 to the third? 4 to the third is 64. What is x squared to the third? Well, remember when I have an exponent raised to an exponent, I multiply the exponents and get x to the sixth. On the bottom, the y cubed doesn't have anything to change with, so I do 5 to the third, which is 125. Let's look at a word problem. The luminosity of a star is the total amount of energy emitted from the star per unit of time. The order of magnitude of the luminosity of the sun is 10 to the 26 watts. The star Canopus is one of the brightest stars in the sky. The order of magnitude of the luminosity of Canopus is 10 to the 30th watts. How many more times luminous is Canopus than the sun? So when we see how many more times, we know we want to divide. And we're dividing the luminosity of Canopus by the luminosity of the sun. And what do we do when we're dividing two numbers with the same base? We subtract the exponent. So we'd have 10 to the fourth, which is 10,000 times brighter than our sun. I'll give you one to try on your own. Let's try a squared to the fifth. Oh, let's back that up. A squared over b to the fifth times 1 over 2a squared. So once you pause the video, take a second to give that a try, and then unpause the video and see how you did. The first thing we want to do is apply our power of a quotient property to the first piece. So we're raising the top to the fifth power and the bottom to the fifth power. There's really nothing to do with the second one yet. Now I apply my power of a power property, which says when I have a to the second power to the fifth power, I multiply those powers and get a to the 10th power. Now I simply multiply my fractions together, and I have a to the 10th on top, and on the bottom, I always write the number first, and then I put my variables in alphabetical order. The last step is to combine those two a's using my quotient of powers property. So what do I do with those powers? Since I'm dividing, I subtract them. I have a to the 8th on top, and the 2 and the b to the 5th stay on bottom. That's all it takes. If you have any questions, feel free to ask. If not, you can move on to your homework.